Hi, I'm Peter Burris, and welcome again to a Wikibon Action Item. I'm very excited about this week's conversation with the Wikibon research team. It's something that we've been touching upon for quite some time, but we haven't really pulled it together. I'll tell you what that is in a second, but here in the studio with me are George Gilbert and David Floyer. Hey guys.
Hi there.
Hi.
And then remotely we have Jim Kobielus and Neil Raden. Jim, Neil?
Hello, great to be here.
All right, so here's what we're going to talk about. David Floyer wrote some seminal research last year describing something we're calling UniGrid, which is effectively a new hardware architecture that makes use of flash memory, very high-speed interconnects to dramatically reduce total latency in a system. And it's going to open up new types of application opportunities, specifically applications that can start bringing together analytics and operations to improve automation, to improve responsiveness to complexity in forms like customer experience, et cetera. Now, this new UniGrid technology, while the hardware is ready, there's an enormous amount of work that has to be done on the software side, as well as in the development world. We need to think about approaching problems differently as a result of these new technologies. But it's going to require a fair amount of time, and it's going to touch a lot of parts of the industry. So, David, let's kick it off. When we think about this new compute model, this new programming model, what are the parameters of the conversation?
Well, first of all, it's a really exciting time, isn't it? So this type of capability, which has been impossible to do beforehand, is now coming to fruition. I'm really, really excited about it. And it's going to make a big difference. And not all the hardware is there, but in 2018, pretty well everything will be there to be able to start this journey. And it is a journey. So the starting point with anything is, what is the business case? Why are we wanting to do this? What are the things that we can, costs we can reduce? What are the things we can do? And the starting point then is to determine with this technology, with these building blocks, how can we make direct business benefits, either revenue generation or reductions in labor, costs or risks. How can we use this technology to apply it to doing that? And one of the differences of building that business case is clearly that we're talking more about real time than we ever did before, trying to get everything done in real time or near real time. So we need to determine what the business processes are that will change. We'll need to determine the business state systems, how they needed to be updated to be able to take advantage of all this AI stuff and other applications around.
And by state systems, means systems of record.
Systems of record, yeah. Yes, that would be a better way of putting it. And what are changes are made to be able to take advantage and make those benefits happening. So let's go through a quick list of the programming types that will be necessary, and they are very different. So in thinking about applying AI, a new systems of record in real time to help systems of engagement and systems of record, we start with what's the modeling phase? The AI modeling phase, obviously the line of business are involved, the data scientists, the developers are involved in this. There's data discovery, there's exploration, preparation. It's a very intensive, data intensive area. And what's more important is that data is probably going to be in many different places. So what is the type of model we need for that? We need to be able to look across a hybrid cloud, multiple distributed data sources, and be able to move the programming to the data. That's a much more efficient way than trying to move all the data around. So that's going to need a hybrid model. We're going to need ways of determining the best way of accessing that across. And then we've got AI machine learning. That's obviously the iterative improvement of the model that's been created. That again is an operational type system, and we need to put in ways that we can do that much better. It's very compute intensive, and it's going to need allocation of resources for it within UniGrid of GPUs and other techniques, compute accelerators. And then if we look at the ones beyond that, we're looking at the inference systems, the output, which can go in many different places. They can go next to the systems of record, or they might go at the IoT level, or somewhere in the middle.
But wherever the action, proximate to the action that needs to be taken.
Where the data from the action is derived. Yes, and those are going to be, again, latency intensive, very latency intensive. And we're going to have to talk about latency budgets. We're going to have to know what the latency is between different parts of this larger network. So it's a very exciting time, and the key things that is different about these, each of these are different models. Each of these is different, and they are going to need latency as a key attribute. And the last item in it, how do we update the systems of record in real time or near real time with all of this extra information, this extra capability, so that they can keep pace with it and so that they can take advantage of it. And one of the best ways of doing anything is to automate it. So if we can remove the requirement for a lot of business processes or steps in a business process, that's the way that we're going to be able to reduce costs very significantly, increase revenue opportunities, etc. So that is the environment that we're doing, and that's the programming challenge ahead of us. What's really important to understand, of course, is that you're not asking everything to be done at once. This can be done step by step.
In terms of the technology evolution.
Correct, yes. The stuff has to work as is within the UniGrid to begin with, but the opportunity is to be able to link these much more tightly together and take step by step, iteratively, improvements in the current set of technologies that are available.
All right, so Jim Kobielus, let me quickly summarize some of the things that David said, and then let me set you up to about what that's going to mean from the development world. So, number one, from a business standpoint, know what actions are going to create the most value. Number two, what data is going to be necessary to perform those actions. Number three, what types of technologies are going to be necessary to take advantage of that data. And number four, therefore, what implementation formats we're going to use from a hardware standpoint. The hardware is dramatically evolving to be able to support an unbelievable array of different approaches. But that suggests greater parallelism. It suggests new declarative languages as opposed to procedural. Jim, take us through some of the challenges that developers are going to face as they try to conceive of these new application styles, build these new application styles, or build these new applications, but very importantly, also build them so that they can evolve, so they can be maintained, so they can take advantage of the enormous new technologies that are on the horizon here.
Thank you, Peter. Yeah, David, thank you. That was great. So I'll just expand on what David has said. First of all, the challenge here in the business case is to reduce time to value on all your workloads, your jobs, your apps. The outcome you're trying to achieve in the UniGrid is to minimize the latency, to find really the shortest, fastest path through the resources, flash and interconnects and so forth, computation, to find the shortest path to accelerate and reduce the latency of whatever job you're building. So it's a declarative programming model. Essentially what it's going to come down to is that developers will not define the path through the data or through the fabric. Rather, they'll declare what they're trying to achieve in terms of latency, in terms of maximum latency on any given application, job, workload. There'll be late binding enabled through this UniGrid middleware infrastructure that will do essentially resource discovery in real time, resource bidding, resource brokering, dynamic orchestration and calculation of the shortest path, and then provision automatically the resources across the UniGrid to enable that, the declarative outcomes you're trying to achieve to be realized without the programmer having to build those orchestrations, that logic into their application. So, like Peter said, a new set of declarative programming models that in many ways will be, from the a programmer's point of view, it won't be so much the old style of procedural programming. Rather, a lot of it will hinge on AI. In other words, AI, in terms of things like Bayesian logic, will be built into the fabric of the programming models that enables you to specify, well, to specify to the infrastructure, to your tooling and so forth, find the set of paths that might be best able to shorten or to minimize the latency through this incredibly complex range of options, and then exploit the shortest paths that are available at any point in time, the shortest paths as determined by this whole complex process of, in a distributed mesh, resource bidding and brokering and dynamic orchestration and provisioning and so forth. That's the new world of provisioning, of programming applications to achieve on a continuous basis, as enabled through this dynamic late binding infrastructure, the outcomes that you're trying to achieve across the UniGrid.
So Neil Raden, we've have experience with something, I don't want to say similar, because we're talking about a level of scale and complexity that while the hardware can support, there's still a lot of software that's got to be built. But when we look back on things like database optimizers, those optimizers had to worry about similar types of problems, right?
Yeah, correct. Reporting on what happened is easy. Predicting on what may happen is somewhat harder. Optimizing is really a pain in the ass. Optimization problems are really the hardest problems there are. And database optimization was a bit of proprietary intellectual property of the database that they guarded very carefully, but they developed it over decades. It took a long time. So you may have something like a cost-based optimizer that would look at a query coming in and say, well, how many records are there in this table? How expensive is this join? Is this the best way to do it? And of course, it doesn't like that. I would think that this would be something along the same lines, but we can close our eyes and we can say, look, we have all of this processing power. We have all of these skilled and trained programmers in AI techniques now and AI capabilities. This shouldn't be that hard. It will be that hard.
Yeah.
Absolutely.
No, this is gonna, sorry, go ahead.
And I think that it's not going to be a cottage industry. You're not going to have a whole bunch of people in open source developing optimization routines for this. You're going to have one or two or three players who do it, and that's going to kind of brand these UniGrids as they from this company or that company.
And that's a big white space.
Well, we know one of them is going to be Amazon.
Yeah.
There's going to be a lot of computer science created not too far from Seattle. Microsoft clearly is going to be a major player in all of this. It's hard to believe that Oracle's not going to be intimately involved. HPE certainly doesn't want to lose sight. Dell EMC, I'm sure there's Huawei and Alibaba. So this is, there's a lot of economic incentive to get going on this, right, David Floyer?
Absolutely, yes. I mean, this is, I think you put
I didn't mention IBM, did I?
I was going
to mention them, but then again,
So yeah,
maybe they'll just rework SNA.
This opportunity is a big white space, and it's going to evolve over time. But essentially, its orchestration and automation is going to be too complex for humans to do. That's the bottom line. We're going to have to use AI. We're going to have to dedicate part of that UniGrid to this process, these set of processes that are required to do this. And it's going to get better over time. And at the core of it, I think Jim put very well, applications have to learn how to bid for resources, how to say, I'm more important than anybody else in business terms, and put their money where their mouth is, or budget where their mouth is, in terms of getting resources, maintaining resources. The orchestration layer is complex, but people will have to talk about latency budgets.
I want to talk a bit, but I want to bring you back to that point you made that humans can't do it. And I want to draw an analogy and see if you guys agree with me. I think we could say that humans can't do it. Humans can do it. They just won't be able to do it at the time it's needed. So it's almost like when I took the SATs 5 or 6 years ago, you know, I was given a scratch book and I did all the calculations myself. And today you can bring a calculator in, and you can use that to do that. But you're still telling the calculator what you know,
Need to
the
do.
kind of,
Absolutely.
you know, what's the broad outcome.
Yeah.
So we'll see a lot of I mean, it's still a testing issue, there's still a design issue.
Yep.
So at the system level, we're still going to have to be in a position to describe what it is has to happen. We're just not going to ask humans to actually perform the calculations. Right. We're going to give that over to the system.
I think there's a very good principle, which is you cannot manage a fast system with a slow system. And we found that out the hard way with all the crashes that have happened over the last few years. You know, company after company has gone down in big, serious ways because of problems, internal problems with people. They're all come down to people. And we've also learned that on aeroplanes, the less you use human beings, the safer they become. And we're going to find that out soon with cars as well.
Right, so you don't want the slowest component to be in control of the entire system.
Right. Slowest component can obviously think in strategic ways that nobody else can
declare what
do.
it wants,
exactly.
set the priorities, but the system's going to have to take more of itself to do it. All right, so George, one of the things that's important here is we're really not talking about a wholesale replacement of how computing is done. David, we're still going to have batch.
Absolutely.
We're still going to have OLTP. We're still going to have client server. We're still going to have web-based.
All
of
big
these
data.
modes. Yeah, we'll still, you know, we'll still have some procedural language stuff, even if it means because we have to maintain the old systems. But we're talking about, nonetheless, a new computing model. But we're not going to freeze everything in the industry as we wait for this. And that includes some of the things that we're trying to do, for example, with stream processing. So this has the potential to bring technologies like Kafka and other technologies more into becoming a full member of this aggregate programming model, George. How's that going to play out?
Well, we've always pretty much, the industry started with batch processing and sort of the next generation as we sort of shrunk mainframes down to minis. The minis were much better at request response or interactive models, but we've been trying to get to sort of real-time or per-event processing so that with perishable insights we can have actionable insights in that same, you know, with that same low latency environment. The issue today is most of the stream processors are really sort of managing or working within their own pipelines. There's only one so far in the form of Kafka that tries to take the incredible mess of systems that can be sources and sinks of all these data, organize it around a hub with a sort of durability where you can choose how much history to keep. Now, the way we can put stream processing on top of that, and we can put essentially batch processing on top of that in the form of materialized views, which is like a database snapshot. So you can get the real-time stuff, you can get the historical stuff, but they weren't completely peers, because if you wanted to replay the stream, it was kind of a,
You're spinning it off a disk.
Yes.
Yeah.
And now that if
and everything stopped. So the only thing worse than disk controlling a system is a human being.
Right.
Yeah. But so now you won't replay history in, you know, all use cases, but you can pull through a lot of history with much greater throughput than you could before. And so the stream processor can become now more of a peer to batch and interactive.
That's a very important point. Okay, so we've had a good conversation about this. Now I want to do some action items. Neil Raden, let me start with you. Neil, action item.
You know, Tableau has been a real success story over the last 10 years. And
Not the quick take, Neil.
Really
an action item based on what we're talking about.
well, I'm sorry, we're still talking about UniGrid.
Yes, we're still talking about UniGrid. So action item.
Oh, I'm sorry.
Neil Raden, programming UniGrid, action item. Neil, go.
I think for those of us who've been around for a while, the idea of some sort of unified architecture to pull all these various systems together generally requires something we haven't even talked about, which is governance. And governance is not a bunch of rules and prohibitions. Governance is really all about trade-offs. And the trade-offs feed right back into this whole optimizer thing.
Absolutely.
Great. Jim Kobielus, action item.
Yeah, look for, as a predecessor or forerunner of the architectures we've been describing for programming the UniGrid, today's distributed query processing environments that work in mesh environments, like IBM Queryplex, for example, is one such. These are a forerunner of the more standardized, open environments for really harnessing all the various data resources across the ultimate UniGrid that'll operate in a streaming in-memory, environment in the future.
George Gilbert, action item.
Okay, so we had touched on this before, but the software that really has to be rethought from the ground up is the IT operations and application performance management. And it's not just so that it has all-seeing eye view of the resources and infrastructure, but that like a DBMS query optimizer, you say what you want done. Like, here's my latency budget, here's my my compute, overall compute budget, here's storage. But this system has to model, it has to be able to model that whole environment. And here's where cloud compute, the public cloud vendors have a big big advantage. They have so much more telemetry and their configurations are well known. So they're, I believe, in the best position to build these optimizer / orchestrator / essentially machine learning and AI based next-gen systems management.
All right, David Floyer, action item.
I'm going to take it from a business level. The potential for improving business return from IT is absolutely immense from these sets of technologies. You cannot overstate what the potential is. The amount of improvement in productivity, in throughput, in new opportunities, the amount that it's going to protect people who take advantage of this from people coming into their space. So there's an enormous business potential. So from a strategic point of view, CIOs, CTOs should understand this really thoroughly. They should start to invest in and make as a prerequisite for investment that it will, whatever they're investing in, will take them as part of the path along this. And they're going to need to put their best and brightest on exploiting this type of technology. First of all, making sure that pieces work within this technology, and then bringing them together and starting to exploit low latency computing as we've never known it before.
Before I do my action item, I'm going to build on something you just said. There's a pretty strong correlation today between the degree to which a company is regarded as a digital business and the degree to which they've adopted the technologies that we're talking about.
Absolutely.
Amazon, Netflix,
yeah, absolutely.
they're already far along these lines. Okay, great conversation about the programming model that's emerging to take advantage of UniGrid. Our action item overall is, when we think about the characteristics of the problems that are now becoming possible to address with technology, increased automation, having the system present itself on behalf of the business, new revenue opportunities by utilizing digital technologies and creating dramatically new classes of service or value propositions for consumers. All of these approaches to building applications are not well formed yet, and it's been a long time coming. We've had people talk about each individual piece parts, but one of the key challenges has been the hardware, underlying hardware structures have not been available so that we could start building them, testing them, imagining how they're going to work, and reconfigure IT around these new types of assets. But that's starting to change. In 2018, all the key hardware elements, flash memory, faster interconnects, improved ITOM that allows for incorporation of AI and machine learning directly in how systems are self-managed and self-configuring, are going to be in place. They're not going to be fully integrated, they're not going to be fully optimized, but they will be in place. And that's going to catalyze an industry-wide approach to rethinking how we think about computing and about computing problems. Specifically, it's going to focus on a declarative approach that starts with the question of what action is going to be taken, what data is necessary to take that action, and then how can we suggest to the system the time and other resources required to perform that business function. This is going to have enormous impacts on how we think about application development, how we think about testing, how we think about DevOps, and a number of other factors. But it's going to be an era of declarative programming that's focused on data, not just for building web pages, but for building true distributed compute models that have unprecedented potential to alter the way business operates. This is going to take quite some time. This is not something that's going to happen in the next few years. The piece parts are in place, and we're going to see it come out of the cloud, the big cloud players first. But by 2025, 2028, we'll see general purpose systems capable of supporting and solving business problems that are unprecedented in their complexity without requiring an equal complexity in how the administration works and the uncertainty associated with the predictability of the costs. Thank you very much. Once again, I want to thank David Floyer, George Gilbert here in the studio with me remotely, Neil Raden and Jim Kobielus. This has again been a Wikibon Action Item meeting.